This is the New York Java Special Interest Group. We've been around since a couple of months after Java was released. We've been around since September 1995. Boy, that sounds like a long time ago now. And we're one of the largest Java user groups in the world. I would encourage you to become a member and follow us. Both of those things, all those things, because we have some really good presentations that we do. This particular presentation is part of our Java How. How stands for Hands-On Workshop series. And today Andres has been gracious enough to do something that we can all follow along with. So let me just, first of all, I was going to ask if we have any newcomers, but apparently everybody has already chimed in who is or is not a newcomer. So we'll just skip that part and go on. And I just, before we get started, want to make you aware of our upcoming meetings. On Wednesday, June 9th, we're going to try something completely different, something we've never done before, which is to do lightning talks. And we've already got some people signed up to do those. 5-minute talks, no pressure, absolute, no, pressure-free lightning talks will be really, really nice to people who do them. And anybody who's signed on to this meeting who's interested in doing one, please get in touch with us either through Twitter or send a carrier pigeon or anything you'd like to do. We'll also have Bruno Souza speaking on that evening, and I have a few details to tell you about that, but I'll tell you about that after Andres's talk. Also, on Tuesday, June 19th, we'll have another hands-on workshop, and that'll be Quarkus, the very well-known platform, and that'll be time to get your machines all revved up and follow along with that talk. Okay, so at this point they always say without further ado. I'm going to do a little more ado. Here we go. Today's talk, we are lucky enough to have Andres Almiray, Java champion, an all-around nice guy, to talk about Layrry, that platform. He's going to do a hands-on workshop, and that means we encourage everybody to follow along as we go, ask questions. I'm going to keep the microphones open so that you can chime in when you want and tell us where you are and what you're doing and whether it's working for you. And if it's not working, we'll help you out. All you need, and there's a slight modification to this slide in a minute. All you need is Java 11 or later, and it says Maven 3.6.3 or 3.8.1. Now, just before this session, Andres informed me that his second example, which he may get to at the end of the session, needs Java 16. Am I right?
That is correct.
Okay, so if for some reason you are now scrambling to download Java, because, well, pretty hard to believe, but if you're in that position, then get Java 16 while you're at it, and you'll be all set to go. Okay, are there any questions before we get started? No? Okay, I am going to turn things over to Andres, and you're going to share your screen?
Yes, I will.
Good.
So just a reminder of what Barry said. Please feel free to stop me at any time, ask any questions. When I get excited about things, I tend to start speaking very, very fast. English is not my first language, so it's very likely right now that we'll get some words wrong. And so please let me know if I need to repeat something. So yes, we need Java, we need Maven. It was kind of obvious that we need Git and some sort of editor. Now you can pick any IDE you want to. It's I'm not picky here, although if you use IntelliJ, you're probably going to have a better time instead of the other IDE. What I'm going to do is, before I share my screen, I'm going to post in the chat the URL to the Git repository that contains the source code that we're going to work today. It's my username, Almirai, on GitHub, and the name of the repository is Layrry Workshop. And so just clone it with Git or use your ID to clone it, and we should be good to go pretty much very soon. Once you navigate to this repository, you'll find that we have two folders, Hello World and plugins. We're going to start with Hello World, and then if we have time, we're going to move into plugins. Now, the idea of this workshop came to be based on a session that I gave to the New York Java special interest group back in January of this year, if I'm not mistaken, January 19. Now, the thing about Layrry is that it's a set of APIs, so it's a tiny set of APIs that allows you to work with Java modules and create modular applications in such a way that you can create dynamically loading applications like application plugins, so you can add and remove content in even taking advantage of the module system, similar to what happens with OSGI. If you did not see this session before, that's okay. That's what the whole point of going into the Hello World application. And so I hope that most of you have already cloned the repository. We have a few more people joining in. So for those that have just joined, just getting started, you will find in the chat a URL for a repository, which is the same repository that I have here sharing on my screen. And this repository contains the source code that we're going to work on today. So once you check out this code, let's show IntelliJ. Where is it? Here we go. It's just a standard Maven plugin. Maven project is not really, things that are not really that difficult to understand, or at least I hope are not really too difficult to understand. Maven is quite a straightforward build tool. There are two README files. The one that I'm currently displaying is called steps.md. And this is the one that we're going to use to get along with this workshop. Now, the first thing that we need to do is verify that each one of you has the correct setup for running the code and doing what we need to do with the code, which is first version 11 of Java or greater, Maven 3.6 or greater. If by any reason you don't have, don't worry too much. The project has set up the Maven wrapper, which you can invoke by using the Maven W command instead of just using Maven command. In this way, we can ensure that the given version of Maven that is expected is going to be used for building the project. And given the nature of the application, we do need to push artifacts to your Maven local repository. That's why we're going to invoke install. And I say this because those that know me know that I cannot wage in a war against Maven clean install. But in this case, we do have to use install. What's going to happen once you invoke install is a series of compilations, and for each one of the sub projects, then a new directory called staging will be created. And so let's move that chat over there. Now let's go into the terminal so I can show you, and this is where you should be seeing as well. So I know I'm going to do a clean first. Oh, that's the right, correct? No, the right direction will be hello world. There we go. And do a clean so there, there's nothing up my sleeve, nothing there. So I kind of have the same setup as you do right now. And if I do an install, this will compile the whole project and generate a few extra files. We'll see that in a moment. Right, here we go. So it should be very fast. Takes less than 4 seconds to build the application. It's quite simple. And here's the last bit that I was telling you about. This is something extra, and we'll see what's going to happen here with these files and these jar files that are being copied into a specific directory. So up to this point, the only thing that we have are the compile bits, nothing more. And if you look at what you have in your directory right here, you see there's a staging directory there, a staging folder. And in that staging folder, we have a couple of external configuration files, another directory called repositories, which we come to in just a moment. Okay, so what this application is a simple hello world application where it has Java modules and is comprised of 6, 7 modules, if I'm not mistaken, and 2 of them are conflicting modules. There are 2 different versions, incompatible versions of the same module name. Now, if we were not to use Layrry, you could not run this application at all because the module system says you can only have one named module, and it can the named modules cannot have version numbers. So we know that there's a binary incompatibility between these different 2 modules. Well, thanks to another API provided by the module system called the module layer, which is the very basis of the Layrry project, is how we can get around this particular problem. So we can have a look at the code and then we can run this application. The code is, the important bit will be here. This starts with the application that we're going to launch, which is in the app module. The main class is pretty simple. It expects 1 argument. If it's not given, then it's going to blow up with an exception, and then creates 2 instances and invokes 2 methods, and that's it. Now the method foo and the class foo will come from one module, the foo module, and bar will come from another module. You can see them on your IDE. There is a bar module and the foo module. Very important is that each one of these Maven modules is a proper Java module, which means it has a module descriptor. There's nothing special about this module descriptor in order to be used with Layrry. It just defines the module name, exports as many packages as you want. In this case, we only have one, so we just want to export that one. And we mark their requirements, the other modules that are needed for the app module to work. So if we were to have a look at foo, for example, there is the foo class right there. And what this foo class does is consume a greeter class that has a greet method. And we look into module info. What this foo module does is exports the foo package, requires log4j, and requires the greeter service. This is the module that has the binary incompatibility. This is the module that for which we have 2 different versions. If we have a look at bar, yeah, as opposed to foo, this one calls 2 methods, hello and goodbye. And we look at foo, the method is called greet. So this is where the binary incompatibility happens, because the greeter class that is used by foo has 1 method with such name, and the greeter class consumed by bar has 2 different methods. We can validate this by navigating to foo, clicking on greeter, and you see that it has the greet method. And if you go to bar and navigate to greeter, you see it has 2 methods. The part of the module system for both bar and foo look very similar. So this is the definition for foo, and the definition for bar looks pretty much the same. This is how we can tell that there are no version numbers for our modules. the greeter service module name is exactly the same, even though we know the Maven module for greeter 1 contains a variation of the greeter class as opposed to what the greeter 2 does. If we look further into the greeter version 1, if we look at the module, here's the module name and exposes this package. And we look into greeter version 2, we look at this module definition, is identical. It's exactly the same. So how do we solve this problem? How do we make an application that can run with all these different modules, even though there are binary compatibilities? So this is where we get to use Layrry. I'm gonna close all these classes and let's navigate into the launcher. We're gonna use the launcher first. Here's my class. Before we talk about this one, let's look at the POM files. The POM file for the application says I have a Maven dependency for foo and a Maven dependency for bar. There's nothing more for it. It's just regular Maven dependencies. Bar says it depends on log4j and version 2.0.0 of greeter. Foo depends also on log4j, but greeter version 1.0.0. Greeter 1 has no dependencies. Greeter 2 also has no dependencies. Finally, the launcher, this is the one that we're going to use right now. Well, let's make it bigger. It has 3 dependencies. The application, which transitively will bring in foo and bar, which will bring greeter 1 and greeter 2, and everything else, log4j, whatever is needed. The log config, here's another module where we have a log4j configuration. So this is just a simple XML file. And now we start to see something called Layrry Launcher. The Layrry Launcher is the API that allows us to assemble the application and run it. What else we have here in this Maven file? This is a custom property, could be any name. I decided to make it exec.input. We'll see that in just a moment, why. And then we have a plugin definition here, which is the exec Maven plugin. If you have not seen this before, it's a Maven plugin that lets you launch a Java process or any kind of executable process. In this case, it's going to be Java. And in the configuration, we pass in the class path for this project, the main class that we want to launch, which is our main class. We'll see that in a moment. And we pass in that property as an argument, which has a default value of Alice if we don't define the property explicit in the command line. Okay. So here is our launcher application. Finally, we get to see a Layrry. I'm going to explain for those that have not seen Layrry before what's going on here. So we're going to construct a series of layers. And we will have 4 layers. And at the bottom of the stack, we have the log layer, this one here, that is comprised of 3 Maven dependencies: log4j API, log4j core, and log config. The current setting for Layrry is that even though it's able to resolve dependencies using Maven APIs, using the Maven resolver, you must assemble the module with all the explicit dependencies. If I were to just include log4j core, it will still require log4j API. And then when I launch the application, it will fail. It will tell me I did not find log4j. So Layrry does not resolve dependencies using transitivity. So if you have a dependency that has, I don't know, like 10 different transitive dependencies, and you look at the graph, if you need all of those, then you need to list them explicitly. That is something that might change in the future. There is actually a pull request out there to deal with transitivity. We'll see when and how that's going to get merged. Next, we move into the next layer, the full layer. Notice that it defines two modules, so the greater module version 1 and the full module itself, and depends on the previous layer, which we name log. The bar layer looks very similar. It also has a dependency on log. It depends on greater version number 2. That's the difference, and also depends on bar. And finally, the last layer is the app layer that depends on both full and bar. So we bring everything together, and the app class, which is found in the app artifact of the app module. And once we do this, once we have defining these layers, we just can build the layers definition. Layers is a class coming from the Layrry API. And once we have this, we can just simply launch the application. We just pass in the module name with the main class that we want to launch and any additional arguments as needed. Now, how we launch with the application, if we go back to the steps file, she'll let us know what to do now. So you go back to the terminal and you copy and paste this, this command line. What should happen, oh no, you need, yes, we have done the install before, so everything is compiled. So what's going to happen is the following. If you have not seen these flags before, AM and PL, those stands for, these are standard Maven flags. The first flag says also make. It means that if you're going to build a sub-project, in this case, it's going to be the launcher sub-project. If it requires any dependencies in the Maven multi-project build that we have, then those additional dependencies will be compiled and executed as well. So what we're saying here, what we're telling Maven is that we want to invoke the following tasks, the following goals on the launcher project. PL stands for project list. But we could also say, also make, everything else is going to be invoked on all those sub-projects. Next thing is the goal that we want to invoke is the exec goal of the exec plugin. That's why we have exec:exec. But we want to also invoke using not the default execution ID, but if you have a look at the POM XML of the launcher, we define an ID called launch. So that's why we have the full definition here. And we pass in a value for that exec input property that we define in the POM file. So let's grab this. I'm going to copy. Oops, it's so weird here. Come on. Or I can just type it. So that will be -am -pl, then launcher. That's the project that we want to run. Then the goal is plugin exec. The goal is exec. The execution ID is launch, like this. And then we pass in a parameter, exec input, let's call it New York JavaSIG. And then we hit enter. We should be greeted with something that looks like this. So we can tell that our input here was passed in as a parameter. We can see the output of the invoking the full method on the full instance that just greet. And we see the output of invoking both hello and goodbye methods on the greeter 2.0 version coming from the bar method from the bar instance. So with this way, we can prove, hey, the application is working. The Layrry works. We have incompatible versions of our modules, yet the application was able to be assembled and executed. Questions so far?
Just one.
Yeah.
No, I'll save it until the end. Go ahead. Go ahead.
Okay.
Okay.
Well, so I launched this using the command line. If you want to launch this using the IDE, which you can also what you have to do is in your IDE, just create a launch configuration, and remember that the app class requires an argument. So if I were to just launch it here, right there, it's likely going to fail because there is no argument. So let's do that. Yeah, typo, yeah. Here we go. This is a printout from the app class as expected. Yeah, there is a failure because I missed passing something else. And that's all right. I guess if I really want to launch this, I just go into edit configurations right here. If you're using Eclipse or some other IDE, when the instructions will be different. Let's see, I rarely launch applications like this from the IDE. So where is program arguments? Here we go. Let's give it another argument. For example, let's say hello New York. And we probably need, yeah, just make it just one argument like that. Apply, and then okay. And let's hope that this time is going to work as I expect. And there we go. So yes, you can also launch it from the IDE. Now this technique is where you create your own custom launcher. And as you can see, there is duplication with what my Maven POM file requires in order to build and compile and place the IDE with dependencies, and what I have to put on my main class, my launcher class, because, well, these coordinates will likely be repeated, right? So for this reason, we in Layrry support a mode for externalizing this configuration. Now, where are my steps? Where are my steps right here? So what we're going to do next?
Yeah.
Yes, question.
नहीं अभी बाहर नहीं आया अभी तक
So probably not.
6 o'clock बोला था उसने.
Oh, sounds like someone on the phone.
Can I go for a walk?
Yeah, go for a walk.
Okay. That was fun. So what we can do also is launch our application without using our custom launcher. For this to work, we need to have external configuration file. We have those already. Remember the staging directory? Here is our staging directory. And let's look at the YAML version of the configuration file first. Just regular YAML file that happens to have the same module definitions with the same names as we saw before. So there is the log layer with 3 modules, full layer with a log parent and 2 modules, bar that depends on log and 2 modules, app that depends on full bar and has app module. And here we have the main. Now, the difference with this and your custom launcher is that this one does not define the arguments that you may pass to your main application. You will have to pass them externally as well. If YAML is not for you, you prefer to use a different format, then we also support TOML, which looks a bit different. It's also a structured format, but we have pretty much the same definitions. We have 4 layers, log, full, bar, and app, with the same dependencies as before, and the same main definition. How do we launch this? For this, we will require the Layrry launcher as an external application. There are a couple of ways that we can get this to work. if I, oh, that's not what I want to show. If I move to now, let's go into, I hope that most of you know what SDK-man is. It's a package manager for Java-based projects. And one of the projects that we can have access, if we look at SDKs here, it's Layrry, and it's right there. So the easiest way to get Layrry installed is through SDK-man that downloads the T file and configures the environment variables for you. If you were not to use SDK-man, you can still navigate to the Layrry project. Going to our releases, we can, the current release is 00 alpha 1. And just grab one of this. Grab the zip file and zip it and configure your environment variables, or grab the tarball, or just the shaded jar, which is available right here. Okay, so in my case, I do have Layrry installed using SDK-man. And if I go back to the terminal, and I do SDK list Layrry, I have two versions. The official release, which is 100 alpha 1, and a local version of a snapshot that I'm just building to test out things. If you were to install Layrry through SDK-man, you will only see this version. Okay, so assuming that you have Layrry installed, it can be invoked just by calling the Layrry command. If you have your class, your environment variables set up correctly. And of course, there's failure because I did not pass in the required parameters. What are the required parameters? A layers config file. One of those two files that we saw is either the YAML file or the TOML file. Those files, as you may recall, exist in the staging directory. So what we're going to do now is invoke the Layrry command, pass in one flag, and pass in also the reference to one of these configuration files. Let's go with YAML. And now let's pass in another parameter. Now let's go with Duke. And let's click enter on it. And we get different output. Now in this case is greeting Duke. So with this, now we can attest that we can run the application using external configuration file. And if we want to run it using TOML, I'll just switch from one format to the other. Let's call .s now. And here we go. TOML also works. So the question, I'm going to show the launcher. Yes, the launcher, our custom launcher is this one. So this is the one that you're going to, either you can launch it using the IDE, or you can launch it using the Java command that I show. Or another way that you can launch this is you will have this jar here. This is your jar, launcher 100. And this, this will require you to either shave all your dependencies and create an Uber jar, or create a class path entry in the manifest for the jar to define all the entries to all the jars required for Layrry, not for the application, because what we need here is the Layrry API, this class, layers, which brings in a host of other dependencies. There is no duplication at all on with parent, because what's happening here, Asha, is that foo has one dependency in its graph, and that is log. And layer, this bar layer could be anywhere else, but also has the same parent. So these two layers are different. but they have the same parent right here. These are not like defining Maven dependencies. These are for defining the dependencies within the layers.
Agreed. But I think in the next section that you had, you have it as with parent foo and then bar. So isn't that log with parent log duplicated?
So yes, I can see what happened. So this foo here, this dependency foo on app will resolve to this, which will eventually resolve also to log, right? And then we do the same for bar, which we'll call log, which will go here. But because this is just the this is an identifier, this the name for a particular layer. These jars here, these modules will be included only once.
Okay. Yep. Thanks.
That's a very good question, because it looks like we have duplication of what appears to be Maven dependencies, like some redundancy in our dependency graph. But in this case, it's not. This is just a reference to a previous layer definition. Okay, so we can launch this by hand, or we can use the external version with these external configuration files. Now, so far, what we have done is rely on Maven to resolve these dependencies, and these dependencies currently exist in Maven local, at least some of them. The greater modules are definitely not posted on Maven Central. They're only available on your local Maven repository. But Log4j and Layrry and a few other dependencies are coming from Maven Central. So we have a mix of from where these dependencies can be resolved. There are cases where you want this to happen. You don't want to host all your dependencies at one location, or you can host it as an artifact repository, maybe it's Artifactory or Nexus or whatever, what have you. And sometimes what you want to do is to have a closed environment, a closed world, where you say all the dependencies are going to come from a specific directory, and they are not even going to be resolved from a Maven repository. For security reasons, for privacy, there are many reasons why you would like to do something like this. We also support this use case, and this is the case of running from a local repository. What we're going to do here to prove that we are consuming from a local repository is first delete a set of dependencies from your local Maven repository. So do not delete your whole Maven repository. We're just going to delete a subset like this from M2 repository, and we have to delete org moditech Layrry examples. So let's go with everything like that. And now it's gone. We can prove that the application is broken by trying to launch it again, as we did it before with external configuration. Doesn't matter if it's YAML or TOML. When we launch this, boom, error. And we can tell that there's those, in this stack trace where Layrry attempts to resolve some stuff using the Maven resolver, which eventually goes into Eclipse Ether and says, well, so I only have one Maven repository, one remote repository that I tried to resolve from, and I did not find the one dependency. In this case was log config, but it should happen for others as well. You have some warnings here. So yeah, that's a problem. If we don't have these dependencies, then the application doesn't work. But if now we look at the staging directory that was created when we installed, as you may recall, look what happens. There is a directory called flat, could be any name you want, but I decided to call it flat. You'll see that in one moment. And we have a bunch of jars. We don't even have POM files. It's just the jars. These jars contain our modules, app, bar, foo, and greeter, and a bunch of other dependencies. And these dependencies are required by Layrry itself. Because if we want to launch with our launcher, we will need these dependencies. But if we want to launch just with the external Layrry launcher, we only need our dependencies here. What the setup that we have currently in Maven copies everything. We could probably do a better job at zeroing in just a small subset of dependencies, but for now it's okay. Because what's going to happen is this is the possibilities of dependencies that can be consumed. That does not mean all of them will be consumed. If we have a look at the rest of the configuration file here, you see there's one called layers local YAML and layers local TOML. So again, two different versions. Let's make it a bit bigger. The previous definition of modules is exactly the same. The only thing that is different is this block right here at the top. It could be anywhere, it's just YAML. So what this thing is telling me is when Layrry needs to resolve dependencies, is going to disable querying any remote repository. So goodbye to Maven Central, Bintray, your local organizations, artifact repository. All those are completely invisible to Layrry when it runs right now. But we also are going to enable one repository with this name. The name could be anything you want to. The layout, it has to be two different types. It can either be flat or it can be default. For now, we're going to use flat because that is the easiest one. And finally, we give it a file system path to where those dependencies are going to be located. And again, this path could be anything you want to. If it's given like this, relative, it's relative to this file, this YAML file. And if you give it an absolute path, then it's going to use that particular absolute path. So this is why we see here this path of repositories flat matches what we have here in the staging repositories flat. Okay. So when we go back to the terminal, and now we make one tiny change and say we're going to consume layers local. We're going to consume the local version of this YAML file. Notice what happens now. The application works. We go back to trying to consume the one that it reads from Maven Central or Maven Local. Continues to fail because we did not move dependencies from our local repository, this flat repository, to Maven Local. It's those closed world dependencies remain in the directory where you put them. They're never going to mix with something else. At least Layrry is not going to do that for you. So in this way, now we can assert that you can have a very private repository and have your application with all these dependencies bunch in. I mean, if you want, you could zip this and then just ship it to someone else. And then if they have Layrry installed, then they will be able to launch your application. Or if you have your custom launcher, you could also point the launcher to this flat repository and then just have it run it. This way you can ensure that no external repository will be queried. There is no need for remote resolution. All the dependencies that are needed are exactly there, shipped with your binaries, and that's pretty much it. Okay. Any questions about? Because now is the time for you to write some code. If we go back into the steps, what I propose to you is that you create 2 additional Java modules with 2 additional Maven modules. One module will be named greeter 3.0, and another module will be named foobar, the combination of foo and bar, which consumes greeter 3.0. We can add as many methods as you want on the foobar class. Have the app module also have a dependency on foobar, and then assemble everything and run it. You have the choice of launching the application using the launcher class. So that means that you have to update this class right here with a new module definition, a new layer. Or you can just launch it using the YAML or TOML files, for which you also will need to define a new layer. Once you have all the changes, just invoke install. And that's it. Then just launch it. So are you up to the challenge?
So I have a question now, a procedural question, which is how would people like to proceed? And how much time would you like in order to try this? Do you want to do it everybody in the same room, or should the breakout rooms help? Whatever you'd like. Everybody just chime in and let me know. Andres, how long should we be quiet while people are working? What do you think?
Well, I wouldn't necessarily say be quiet, but
how long should we allocate? That's a better word, allocate.
See, I was thinking that I could do things alongside, but then some might get distracted by the things that I'm doing and saying instead of just trying out. So, but I mean, I'm open to ideas. I mean, because I really want you folks to have the hands-on experience.
Okay. Do people want to work independently, or would you like Andres to help guide us through this? Nihad, Rodrigo, Mike, what do you think? Oh, okay, we're losing Paul.
Yeah.
Thank you for coming, Paul.
Yeah, thanks for coming, Paul.
Yeah, thank you for the info. Have a good evening.
I'm here. Just running after the babies.
Oh, no. Oh, my gosh.
You can hear her in the background.
You got your hands full there.
Yeah. What time is there, Andres?
I'm sorry?
What time is for you?
It's 22 minutes after 1 in the evening.
Sorry for that. We should send you some coffee.
That's right.
No, if I were to drink coffee right now, I would not sleep for the whole duration. I'm going to say something that will sound heresy. I do not drink coffee, and I'm Colombian.
Oh, boy.
Oh, man. You're going to have a problem going to Brazil now.
Yeah. Also because I'm a vegetarian. So, I've been to Brazil once. And Otavio took me to a churrascaria.
Oh, nice.
It was fun because, well, you could see these big plates of meat for those that love meat. And I asked for a salad, which was the size of my fist, really small.
Oh, boy. Okay, Andres, I'm going to leave it to you to decide how we proceed from here. You've described the project for people to try, and use your judgment. Everybody,
Okay.
I urge you to take advantage of the challenge, the project.
Right. So we have here the instructions. I left out a few bits because that means that, well, you have to know how to create a Maven module and how to arrange the dependencies, and you can pretty much copy and paste from an existing greeter and existing foo and bar, and then just change the names or model info. But even by doing copy and pasting, some things might not be assembled correctly, and that's where, well, asking questions will be the way to go. So I guess while you folks are giving it a try, so this is what I'm going to do. I'm going to close all this, and if I were to follow my own instructions, I will start with this, which is, let's grab one of these modules and copy it. Let's change it to greater version 3.0. Not going to add it to Git right now. IntelliJ is very helpful and tells me that I have a duplicate here. Yeah. And this name is wrong. Now let's change that to 3.0. That's fine. And my root project will also need an update. If I don't do this, Maven will never see it. Here we go. So far, so good. The next thing I'm going to do is copy foo and create foobar. And do again, do not add it to Git right now. And I'm going to delete this IML file from IntelliJ. Going to the POM file, change this name. And then let's call this foobar. And what else do we need to change? This dependency right here. There we go. 3.0.0. The last thing we need to do is go back to the root and include the foobar module. So far, so good.
And now I want to ask a question. Can you clarify again why you removed the IML files?
Right now, I removed the IML file because when I refresh the Maven settings, I will have two IML files with one with the correct name and another with the wrong name that is no longer needed.
Okay, thank you.
So we have one more extra module, so that's good. We have the second extra module, that's good. What we're missing is that app depends also on foobar. So we go back to that POM file. Let's see here. There we go. And now we can do this, copy and paste and say foobar. But notice that it's in red for two reasons. I have not refreshed my Maven settings yet. And secondly, this foobar module does not have a version number right now. Why? Because I'm making use of Maven dependency management. Here you can see I have a definition for some of the Layrry APIs. There's foo, there's var, and there's JUnit. Because I'm using dependency management, then these two projects may be consumed without having to specify a version. This is standard Maven. So now I have a choice. Do I specify the version explicitly here and let it go like that? Or I make it work like the others? It's up to you. Personally, I will make it work like the others. So that means going into the roots, look into the dependency management block, copy this, paste, and rename it to foobar. And now I think I'm ready to refresh my Maven settings, which will make the two additional modules that we just added visible to Maven, and all the dependencies should be in place, even though we know part of the code is still broken. Okay, so I have no problems here. And if I go to app, it's no longer red, so it's being taken into account. That's good. So far, so good. Okay. Let's close everything again. Let's move into our greeter class. Yeah. Two related problems. What is IntelliJ telling me? Yeah, the full class is doing something weird. Why? Well, we still remember that our dependencies are not yet working correctly. So I'm going to not pay much attention right now to IntelliJ. and we'll fix that in a moment. So I'm just going to create a method here. Actually, we just can simply do something like this. New York JavaSIG. Make sure that it's exclusive to this user group. And what else are we going to say here? This is return at New York JavaSIG. It could be anything you want. Just gonna leave it just like one method. This makes sure that this implementation of greeter is again completely different from the other two that we have. Our module definition remains the same. We have to have the same module name and exporting the same package. Right. Now let's go into foobar. What does foobar says? We depend on greeter version 3.0.0. That's good. We now have to have a new class renamed to foobar. Rename the package also. Rename directory, and this will be foobar now. Okay. Right here. We have our class foobar as a method foobar. And now this method should be New York JavaSIG. There we go. It says we have problems. Why? Because, well, our module descriptor now is broken. We have to fix it. Our module name should be foobar. And the package name is different, right? You just need to export a different package. And everything else remains the same. So far, so good. The next thing we have to do is go into our application. We have three dependencies, foobar and foobar. We have our main class here. So this was a problem with the rename. So we can fix that. Sometimes IntelliJ is not as smart as we think it is. So import that.
Bite your tongue.
Sorry?
Bite your tongue. IntelliJ not being as smart as we think it is.
Well, where is the problem?
Yeah.
Is it IntelliJ not being smart, or is it me not being smart thinking that IntelliJ is smart?
There we go. There we go.
So what I'm going to go now is invoke the foobar class with the foobar method. Now, of course, it's in red because it's a modular application. And we are missing the last step, which is making sure that the app module descriptor can refer to this. We just have to go to the module descriptor here and say, you know what? I require one more thing, and happens to be the foobar module. Once we do that, we'll go back here and hey, no more red. So to recap what we have done so far, we created two modules, greeter 3 and foobar, and changed the code so that now those two modules do something completely different to what we had before. Our app module now has a dependency on foobar and wires up the invocation of the foobar class and the foobar method. And I think our code should be compilable right now. We can do that. We can verify that by asking IntelliJ to rebuild the project. Let's see what happens. Rebuilding, searching, parsing, blah, blah, blah. Yep. No errors. I hope that on your side is exactly the same. But if we run our application right now, we won't see the changes because we did not update the launcher. Let's go into the next step which is look at the launcher configuration. We go here. What do we have in our POM file? We include the Layrry launcher API, so that's good. We include our app module, which brings in everything in transitive dependencies, so that's good. So Maven will be happy. And we have log config. All right, so far so good. Our launcher class has this. So what we can do now is add a new layer. Like this. With any name you want to. I'm going to choose foobar for obvious reasons. This depends on Gritter version 3 and on foobar version 1.0.0. And finally, the app layer. We have a dependency on this new layer. Okay. So because I have a launch configuration, if I were to just run the main class here, I will expect things to work and we will see a different printout now. Let's see what happens. Whoa. Did not work. Can someone tell me why? Can someone tell me what kind of error do we have here?
I have to confess myself that I do not know. I'm
Well,
staring at it, but I can't, I don't. Anybody? I'm not sure.
the key is in these lines. So what happened before is that we were able to launch the application, right? And then I did something. And then we changed code. And now it doesn't work. So what's happening here is that the first time that I run the application, I have all the artifacts available on Maven local. Because the first thing that we did was Maven install. But remember that a few minutes ago, I deleted every single artifact from these examples from my Maven local repository. So even though IDEA or your IDE will be able to compile the code, what the Layrry launcher is attempting to do is resolve those dependencies from a Maven compatible repository. IntelliJ does not publish automatically those jars because I didn't tell it to do something, right? So I could just do it on the command line, do Maven install, or I can just do it from here, I believe. Let's see, is it lifecycle? Yeah, I can just invoke install here. And hopefully it's going to invoke install in every sub project. I rarely use these from these facilities from IntelliJ. So let's see if it actually works. Run the Maven build here. Let's see what happens. Yeah. So the moment that you see here, the full reactor tells me that it's going to do the right thing. It's invoking install on all the sub projects. So now I have the dependencies available from Maven local. If I run the application once again, then this should work. Hey, here we go. We have the next printout. So this puts into evidence one thing that needs to be on your mind if you decide to build modular applications with Layrry. That is, Layrry will attempt to resolve dependencies from Maven compatible repositories by default. If you make any changes to your code and you do not publish those changes to a Maven repository, then either your application will not start or you will get an outdated version of those dependencies. So just like it happened with me, that I completely forgot that I deleted the dependencies from Maven local, bear in mind that this could happen to you as well. So when working with Layrry, it will be quite common to keep invoking Maven install for all your projects. So if you want to always invoke install with test cases enabled, or just do skip test or some other stuff, then yeah, it's up to you. This particular project does not have any test cases, so that's why it was fast. But for some other projects, well, if we should always be having test cases.
So at this point, I have a question. Is there any way that that can be made more foolproof? I like it when flows are set up so that it's difficult to get into to paint yourself, let's paint against the wall, I guess, the way you did. You no problem getting out of it, but is there some mechanism here that we can use to always remind ourselves that this has to happen? Or is that?
Let me think. One thing that we could do also is that everything that I show here with the external configuration files, such as the local configuration here, this is just another view of the Layrry API. So if I really wanted, I could write this code here. So let's put it right here as a reference, and looks very ugly in terms of layout. But let's see, I believe I can call resolve. Yes. And I can say remote resolve. So, wait. Don't recall how to do this.
Oh, we don't have to. I don't have to see all the details. I'm getting the idea. So
yeah, so you can do it here in the API. But so if we were to do this, you still be missing one step, which is collecting all the dependencies into the right format, in the right layout, into the right path.
Okay.
Right. So where I do this, we can go into your root POM directory. Yeah, I mean, not POM directory, but the POM file here. And at the bottom, let's make it like this. I use the Maven dependency plugin, which by inheritance is going to be applied to every single sub-project in my Maven build. And it's going to copy all the runtime dependencies into a specific directory. That's how you can tell the name. I could change the name to anything I want to. But it only happens during the install phase. It could happen during any other phase you want to. But this invocation, this execution must happen. So if you wire up your build on the command line so that the copying these dependencies always happen given, I don't know, a certain active profile, or in my case, every time that I do an install, then most of the times I'm not going to miss it. Okay. But if I were to launch this using the IDE, I will have to find a way to have some sort of previous step where this Maven plugin execution happens. I am not very familiar with how to do that in IDE, not even in IntelliJ, because I'm kind of a weird developer. I use, I'm sorry, Barry, but I'm gonna say it. For me, IntelliJ is just a glorified text editor.
Okay.
So I'm pretty sure there is a way to create not necessarily a pipeline, but some sort of workflow where you can have previous steps for a run configuration in such a way that you can instruct Maven to do stuff before you want to run the other operation.
Okay, thank you.
Okay, so well, I'll try to do this slowly, but of course, because I know the code, I kind of like just did it. And we've been doing this for close to 20 minutes now. I hope that was enough time for you folks to follow along the instructions. Hopefully I didn't jump too much around from one place to another. I tend to just, I'm a very disorganized developer in this case. When I know where I want to go, I just click and point all over the place, and then boom, suddenly code works.
I don't think you need to apologize. It's fine, as far as I'm concerned. So.
Any questions from anyone? And I don't know if everything that I'm saying is making sense or not. Let's look at the steps. Did I miss something? So we created the modules. We updated the app class and foobar, and we updated the launcher. Did we update these files? We did not update. Okay, that's easy. So we can go here and copy this one. And that's one of the problems with YAML, significant white space. Good thing about IntelliJ is that it tells you that I have duplicate keys. Okay, so let's get around that. And let's fix this, and let's fix this. And finally, let's add this module. We can do the same thing for TOML. So let's go back here and copy. This will be the foobar layer with the foobar module greater version 3. And now we add a third parent called foobar. And those are all the changes. There's nothing that we need to install, but you want to be sure we can call install on the command line, or just going to be use a shortcut here and just copy that files, because that's exactly what's going to happen. Yes, overwrite. So we look here, that's the updated version that has foobar, and the same goes here. Goodbye, Nia. Thanks for joining. So we go back here in the command line, and I can say Layrry, layers config, staying, layers.yaml, and let's pass some parameter. And it has the latest module. That's good. And if I did it correctly for TOML, we should have a similar output. And it also works. Great. So that's it. Now, there are two main reasons to use this API, Layrry, with modular applications. The first one, which is what we have seen so far, being able to construct or assemble an application with conflicted modules. The second one is being able to change the behavior of an application while it is running. So in a way, having some sort of application plugins. Layrry allows you to add and remove layers at runtime. This is quite an interesting restriction that the module system has, is that if we look at our modules here, these module descriptors, this DSL gets checked by the compiler. If I make a mistake and I don't have the appropriate module available, then it will tell me immediately. If I were to, I don't know, use something like that, that's fine, but this is wrong. And foobar, that it's a warning if I'm not mistaken. If I were to mess up this DSL in another way, It will tell me immediately, and the application will never compile. So the compiler looks at all the possible modules that you want in your application and tells you this is going to work or not, and assembles everything, and off you go. But once you do this, there is no way that you can change it unless you recompile. So how are we able to change modules while the application is running? And this is the other feature that Layrry allows you to do. It requires a little bit more work to get around it, but I was still going to show it to you. So if you were to look at the repository, the link that you have at the beginning, there's another directory called plugins. What you have here is a Vertex application that can have plugins being loaded dynamically. And let's see what happens. For this one, oh, it says JDK 6. That's a big mistake. This has to be JDK 16 in order to work. Why do we need 16? Because there is one portion of the application that uses how do we call this? Text blocks or multi-line strings. It was added as a preview in 15, but added as a normal feature in 16. So the difference is that if you were to use 15, it would still work, but you have to add the enabled preview flag. And if you use 16, then it just works. So that's what we're going to see.
6, 16, it's almost the same, right? Just one digit.
What's a 1, right?
Yeah, really.
It's not very significant. But yeah, that should be 16. Sorry about that. So what is different about this application? We have, if we look at the modules, don't add it. Don't bother me IntelliJ right now. We have our core modules, log config and core, and we have plugins. And in plugins, we have 3 additional submodules: greenkeeping, membership, and tournament. This is supposed to abstract over an application that can handle golf tournaments. So that's called what is called links. Anyway, in the core application, we can see a few classes. Well, it's only 3 classes right now. Let's start with the module definition. Yes, we're making use of Vertex. So this is actually a serverless application. It showcases that Layrry can work with any kind of Java application, even serverless. In the session that we had in the user group early in January, I showed a JavaFX application. Okay. So again, we have a module that has its own name, has some requirements, requires transitive for Vertex. That means we can change the version for Vertex. Here we export 2 packages, core and core SPI, that contains these 2 classes. And what is important about this thing, just like in modules, we can use any kind of services that we expose. Services are just classes that implement domain-specific interface. So here we see one of such interfaces called router contributor, which is the interface that we see right here. And this other interface is coming from Layrry. And this interface is the one that allows Layrry and your application to react when a new plugin is added or when an existing plugin gets removed. I believe Layrry Links is the application which just starts Vertex and adds a vertical, which is one of those core classes that we see here. Our domain-specific interface provides one interface and one method. So our plugins will likely implement this interface. And finally, the vertical. This is standard Vertex code with one twist. So it creates a vertex and creates a router and set up some stuff. And here's this little thingy here. It goes through the set of entries in a map called modularized. It could be any name you want to, and registers everything it has, because when the application gets bootstrapped, it will try to find if it already has any plugins. If it does, then it will initialize them. If there are no plugins, then there are going to be some default routes added to Vertex, and nothing else will happen. Let's look at the module and navigate to this class. This is our class. What this thing is doing is keep track of the plugins that get added and removed. This is again our entry point to our own logic from the Layrry platform. So when a plugin gets added, what's going to happen is that we're going to add it to this map. It's a static map. And if we are running, if we have a router, then we're going to contribute all the routes that are coming from that plugin. We will see what happens in a moment. And when such a plugin gets removed, then we unregister all the routes that were contributed to that plugin by that plugin before, then remove it from our current cache, our module layers cache, and nothing else happens. So the magic occurs in these methods: register and unregister. Again, this is just the entry point. And what happens in register is that we load all the instances of that, again, domain-specific interface. And we go through all those instances, figuring out, oh, do I have that layer already? Do I have that plugin? No, I don't. So I'm going to install it. And this is where our custom plugin contributes additional routes to our existing Vertex router. The unregister is the other way around. So we're trying to find all the routes that are provided by a particular layer and then remove them from the router. Once we're done, so that's this whole block, we just remove that routes, that layer, and there's nothing else. If we were to look at the implementation of each one of these plugins, like this, this plugin implements the domain-specific interface, router contributor. So it must provide an implementation of this method, and that's exactly what it does. It has a reference to the router, defines a couple of routes, passing some, the method that, well, it definitely knows how to handle that particular operation, and puts them together in contributions, and there's nothing else that needs to be done. The same thing will happen with the other plugins. There's one more thing that needs to happen, which is register our router contributor service. How do we know we need to do this? If we go back to our core, here's where we make use of those instances. We simply say our core will require every single implementation of this interface whenever they happen to be available. And the Layrry plugin lifecycle listener will make sure that those instances become available when a new plugin gets added, or those services get removed when a new plugin gets, when an existing plugin gets removed. So now I can go into the terminal and change directories. Let me check if I have the correct version of Java, version 16. That's good. So the next thing that needs to happen is install. Boom, it's okay. Now this project also created a staging. Let's see what I have in the staging. A bunch of jars, a layer configuration file, and some properties. If we look at the layers configuration file, We have a few layers. So there's the vertex layer, it's kind of like the common layer with a handful of modules. Notice that in this case, I'm not using version numbers. I'm using some sort of value placeholder. We'll see from where these values are coming in a moment. Then we have the log layer, similar to what we had in the previous project. The platform layer with 2 modules and 2 parents. And then 2 special layers here. Plugins 1 and plugins 2. Why call this special? Because instead of defining modules as the other layers, we're defining a directory with a path. This path is relative to this file. When this happens, Layrry is going to listen, is going to watch that directory. So when we add jar files, zips, and tarballs into that directory, those will be seen as application plugins. When a new file is added, that means a new plugin gets registered, and that triggers the addition of a route to Vertex. And when an existing jar from that directory gets removed, that means the plugin gets removed, and that means the route is going to be removed from the route. So we have 2 different directories. Those we can have as many as you want, or you can just have 1 if you want to. In this case, we decide to go with just 2. So now that I have everything again, oh, the versions, I almost forgot. These are the versions. These values get generated automatically by the POM file based on a template. We can have a look at that here. The root POM file, somewhere in this build, let's see, where is it? Something about resource filtering. Maven resources, here we are. The definition of the resource plugin says I'm not going to inherit it. So that means only the root will have this configuration. The default execution copy resources during the install phase. So it's going to copy those resources. And what's going to happen is the output directory will be staging. So that's one thing. And it's going to filter everything that is found in source layers. So what do we find in source layers? The layers file, which is exactly the same as we saw in the command line, and the versions property, which does have expressions here. These are Maven expressions. These values come from the POM file. These values are defined right here at the top, right there. You can override those using the command line if you want to, in case that you need a different version of Vertex or something else. So that closes the loop there. And now what I can do here is launch Layrry. I think, yes, Layrry, and say layers config, staging layers, pass in the properties file as well, the versions properties. I'm going to launch it in the background. There we go. So this tells me I'm ready to browse to this URL, and I have routes and members. Let's go here. I have members and I have this JSON output and routes, and that's the only thing that I have right now here. Okay. Good. So notice what happened. I'm outside of the application. Let's look again into the staging directory. This directory is being watched by Layrry, and this directory is also being watched by Layrry. These 2 plugins are outside of the scope of the application. I'm going to copy from staging plugins prepare the Layrry links greenkeeping plugin into a staging route plugins version 2. There is some output coming from the application running in the background. There's a new path called greenkeeping activities. Let's go back to the application and, oh, look at that. We have a new URL. There is new behavior in the application, and I did not need to restart it. So I can do the same for the other plugin, which will be tournament. There we go. Copy tournament. There is a new path right there, and there's tournaments. Awesome. Let's remove greenkeeping. That means removing from staging plugins. No, not plugin prepare. Is I'm doing the wrong tab. That will be from route plugins to. And we're gonna remove greenkeeping. We got an output here, and now greenkeeping is gone. As simple as that. Well, of course, this is caching, but there you go. This is the live application. And we could, I mean, this is as simple as it can get. The only thing that we need to do again is handling whenever a plugin gets added and whenever a plugin gets removed. With your custom code, your custom logic, whatever is specific to your application. In the JavaFX application that I showed a couple of months ago, I did things a little bit more elaborate to register the plugin in the UI thread and keeping tabs on some UI widgets. In our case here, Vertex is simply saying, let's add new routes or remove routes. So you could create a Spring Boot application that can also behave in a similar way. I mean, it might not be HTTP routes, it might be some other sort of, maybe you'll need to add additional domain classes that they handle it with Hibernate, or maybe it's some sort of metrics or measurements that get added to your application given certain conditions. But you don't want to ship all those metrics or all those measurement collectors with the application on the first go. You just want to activate those whenever they're needed. So just shipping additional jars and then just putting them in the right directory will activate those capabilities. And when you do not need them anymore, then just remove the jars and then your application is none the wiser, and nothing else is going to be, nothing is going to obstruct the normal operation of your application. And I guess that's the reason why I got involved into the Layrry project, because being able to change the behavior of an application while it's running in such a way that the changes are isolated, and that I don't break down the application with some silly memory leak problem, then yeah, I will certainly take it. So I think that all that I have for you and on this particular topic, in case that, well, you have any questions.
How we do? Any questions? I think you've said everything and demonstrated everything.
Well, I certainly hope so.
What?
I certainly hope so.
Okay, yeah, no, I exceptionally clear presentation, especially since, what is it, 2 in the morning for you now?
Yes.
Right. If you will unshare your screen, then I will just make some concluding remarks. And I hope my concluding slides, my concluding whatever, I hope I'm showing up there. We'll see. Anyway, once again, I want to thank Andres. Really nice presentation. And wow. One question. Where did the name come from, Layrry?
So Gunnar, the creator of the software of the library, said there are 2 reasons to do it. One, he wanted to have a name that will be easily recognizable. that was not taken, and it's a play of words with layers,
Ah, okay.
right? So that's why it has a Y in the middle. It's not Larry, it's Layrry.
Yeah, yeah, yeah.
And the other one is that,
Layrry. Oh, I got it. Okay.
yeah, exactly, Layrry.
Okay.
And it's the name Layrry. There are two names that are highly associated with Java, and it's neither of them. It's not neither of these two people. It's not Larry Page. It's not Larry Ellison.
Okay.
The other reference is Laser Suite Larry, because Gunnar likes the game.
There you go. There you go. Okay. All right. Well, thank you very much. If you missed any part of this or some part of it brushed by too quickly for you, then I remind you that we'll be posting this on our, whoops, there we go. We'll be posting this, a rerun, a replay, an instant replay, or not so instant replay on the New York JavaSIG YouTube channel very shortly. And please join us for our upcoming meetings. Bruno Souza will be talking on Wednesday, June 9th. Plus, we're going to be doing something new. We're going to be trying lightning talks during that session. Now, it says take the poll. And the poll is, Bruno has offered to do a few different titles for his talk. I'm going to put up a poll and launch it. And I would appreciate it if everyone present would vote for one of the possibilities.
So how can I vote on all of them?
I don't think you're allowed. It's not, what is it called in New York? Something choice polling?
So while this poll is happening, another thing that I can say is we have been testing Layrry with popular microservices frameworks. Spring Boot looks like may work. Micronaut has some issues with split packages. At least that was in version 2.4, but there is already version 2.5.3. That's another thing that I need to check. Helidon is a fully modular framework, although it does not work correctly with the service loader in certain cases. That's not a problem with Helidon, so it was not designed to work with how we want to do things with Layrry. And Quarkus is based on Vertex, so some of the things should work, but it's not fully tested. So this goes, what I want to go with this is that we are definitely looking forward to figure out ways so that Layrry can work with the popular microservices framework in case that someone would like to build this kind of application for serverless.
Okay, all right. And speaking of Quarkus, we have a hands-on workshop coming up in June 22nd. Please become a member, follow us, join us. We'd love to have you. Thank you again, everybody. We'll see you soon.
Thank you again.
Thank you,
See you
Andrew.
another time.